Hey everybody, this is Mr. McKee again with SEC 210. Today we'll be going over lab 17.1.7. Let me just verify that real quick. Yep, 17.1.7, which is exploring DNS traffic. Alright, let me get that back where it was. Alright, in this lab I'm going to be using a Windows 10 virtual machine using VMware workstation. Alright. And remember, first thing you want to do though, make sure you have a snapshot. Like, see, I have a, let's see, manage snapshots. Notice I have a snapshot back from October 3rd of actually last year. All right, just in case you mess something up. Usually not a big deal with Windows. I haven't come to find out, but especially if you're using Linux, you can do some damage there. Now you will need internet access. Notice here I don't have internet access on my VM. What I'm going to do though, let's see what I got. I'm going to turn on DHCP. Oh, it's already on. Well, in that case, let me do this. I'm going to change my settings. Bridge to automatic. All right, there I've got internet access now. And what you can do, I'll go through this, but I mean, obviously you can go to the command line, ipconfig. Right. Notice I'm not using my local when I shoot at 168.254.0 network. I'm using this NATed network. All right, so I have NAT set up on my virtual machine, but don't worry about that too much. As long as you have internet access, that's the big thing. And you can also do this on your physical PC if you want to, because you're going to install Wireshark if you don't have Wireshark installed. But it's always good. Any kind of computer security issues or labs you're doing, it's better to do that on a virtual machine, so you can, if you cause some kind of issues, you can restore it back to where it was. Alright, so let's see, exploring DNS traffic. Wireshark is an open source packet capture and analysis tool. Wireshark gives a detailed breakdown of the network protocol stack. Wireshark allows you to filter traffic for network troubleshooting, investigate security issues, and analyze network protocols. Because Wireshark allows you to view the packet details, it can be used as a reconnaissance tool for an attacker. In this lab, you will install Wireshark and use Wireshark to filter for DNS packets and view the details of both DNS query and response packets. And we need a PC with internet access and Wireshark installed. It says Wireshark installed. We're going to install it first thing. All right, so download and install Wireshark. All right, so I'm going to go to my virtual machine, open up a browser. All right, Wireshark.org. All right, notice you can download it. First thing comes up. Okay, so I'm going to assume most everybody has a 64-bit Windows machine, but say if you don't, you can go to the search box for Windows, type in MSInfo, and that'll show you what kind of operating system you're using. I'm using Windows 10 Pro, using a 64-bit processor. All right, there's my CPU. All right. But I'm going to do the 64-bit download. All right. And I'm just going to click save first to save it. All right. It's not that big, 57.4 megabytes. All right. Now it's been downloaded. I'm going to hit run. All right. UAC, you know, it's user access control is turned on, so yeah, gotta hit yes to allow it to download. And I'm going to keep all the defaults here. Space required 193 megabytes. All right. All right. Keep everything the same. Don't install USB PCAP is not checked. Make sure that's not checked for what we're doing. Click install. All right, so while that's installing, let me go to these instructions. All right, download the latest stable version of Wireshark. We're doing that right now. Choose the software version you need based on your PC's architecture and operating system. We're doing that. All right, follow the on-screen instruction to install Wireshark. If you're prompted to install a USB PCAP, PCAP is packet capture, so NPCAP is network packet capture, USB is USB packet capture. Do not install USB PCAP for normal traffic capture. USB PCAP is experimental and could cause USB problems on your PC. All right, looking back at my virtual machine, notice user agreement. I'm going to click yes. Install. You can install. I'm going to leave all this unchecked. All right. So start Wireshark. Select an active interface with traffic for packet capture. And remember, I'm using a virtual machine, so there might not be a lot of traffic at all going across my my network on my virtual machine right now. All right. And one thing to remember too, it's going to want you to restart this virtual machine or your physical machine wherever you're installing Wireshark. So we're going to do that before we get anything else going. All right, I'm going to hit pause, and then I'll be back as soon as this thing's done installing. All right, so it only took like a couple seconds. And hit next. All right, complete Wireshark. Notice the version 3.2.7, 64-bit. Your computer must be restarted in order to complete the installation of Wireshark. Do you want to restart now? I'm going to click yes. All right, and I am going to pause the video again until it's back up. All right, so my virtual machine is booted back up and I'm logged in, so I should be good to go. Now, one thing to remember about these instructions, they have instructions for Windows, Linux, and Mac OS. So just understand that. All right, so let's start Wireshark. Now, what I could do, go to start, but if I just type in Wireshark, it finds the app. I'm going to put the app on the desktop, matter of fact. Here, let me do it. Wireshark. Will it let me? Let's see. Pin to start, pin to taskbar. There we go. All right, now it's on taskbar. So if I close it down, it's still there. All right, so when Wireshark first loads, notice you might not have a lot of traffic on all your interfaces. All right, I actually do on Ethernet 0. You can see it right there. If you mouse over it, it tells you your IP address. All right, so I'm going to do this full screen. All right, so select an active interface with traffic for packet capture. I'm going to click Ethernet 0. All right, you'll start seeing traffic going across that interface. All right, in Windows, enter ipconfig. ipconfig flush DNS. Right. Successfully flushed the DNS resolver cache. All right, and number 2 right here on step 2 is actually Linux. All right. All right, so the command prompt or terminal, type nslookup. All right, and notice right there, that's telling me my IP address. right. And notice we have a lot of traffic coming up on Wireshark in the background. All right, so enter the domain name of a website. The domain name cisco.com is using an example, so www.cisco.com. All right, notice there's the domain name, or there's the URL, there's the address it's resolving to. It has an alias. Okay, type exit when finished. All right, back to the command prompt. Close the command window. All right, click stop. Capturing packets is the red square. All right, so we've stopped right there. All right, so part 2 is explore DNS query traffic. Observe the traffic captured in the Wireshark packet list pane. Enter UDP port. All right, so we're sorting by just UDP dot port and double equals 53. All right, so everything that shows up, port 53 is DNS, so that's showing you just the DNS packets. All right, note the supply screenshots are just examples. Your output may be slightly different. All right, select the DNS packet that contains standard query. All right, and notice under info. All right, and we're looking for and www.cisco.com. All right, so like this one right here, there's one. Here's one. Okay, not a response, but actually a request. Let me go down to this one, this one. All right, so we clicked on that one. In the packet details pane, notice the packet has Ethernet 2, user data protocol, and DNS or domain name system query. All right, so what it's talking about is, see Ethernet 2 right here? All right, in the packet details pane, notice the packet has Ethernet 2. I just said that. IP version 4, right there. User datagram protocol, right there. Notice ports and domain name system query. All right, expand Ethernet 2, and I'm gonna, okay, so that's already expanded. Observe the source and destination fields. All right, notice source. All right, notice destination. This is showing you the OUI of a MAC address. The first three, well, I guess you can call them octets, but 24 bits out of the 48 bits. All right, so instead of the 00:50:56, it's resolving that to VMware. It just knows what that the OUI is, and that's just the manufacturer of the interface or the network card. All right. So what are the source and destination MAC addresses? They're right there. Now to be specific, to be completely right, you can put the actual IP, all these octets, the 00:50:56. But if you put the VMware E199F4, that's still technically correct. All right. Which network interfaces are these MAC addresses associated with? Okay, and to find that, all right, so let's go here. And notice VMware, both of these, because I'm using a VMware virtual machine. If I go to command ipconfig/all, all right, notice the physical address of this interface that I'm on right now on this virtual machine is 00, where's that? 0C29, all right? Now we're looking at source now, and 36F139. So that's my machine right here. That's my virtual machine. But now destination, that's also a VMware virtual interface. But to find that, let's see, which interfaces are these MAC addresses associated with? Let me see if I can find it real quick. So if I do this, NAT, let's see. Click up here, where is that? Virtual Network Editor. Alright. Notice here, I've got two virtual switches. Alright, the 192.168. What is this? 150. Where's my IP addresses? 153.130. Alright, that's mine. 153. So it's definitely using this. In VMnet 8, that's just that's more or less your default switch for VMware Workstation. Let's look at the NAT settings. Alright, gateway IP. If you guys don't have VMware, this might not make as much sense, but just notice right here, there's my default gateway for this NAT virtual switch, 192.168.153.2, and notice 153.2. So that's my default gateway of my NAT, my virtual switches NAT, or virtual networks NAT, not virtual switch, but virtual network default gateway interface. Alright, so that's what that goes to. Alright, so let's expand IP protocol version 4, and I'm going to do a full screen here. Alright, notice there, source and destination. What is the source and destination IP addresses? They're listed right there, which we were already looking at them, because if you close that down, it still shows those two addresses. Which network interfaces are these IP addresses associated with? Alright, I actually just showed you guys that already. Alright, so expand the user datagram protocol. I'm going to minimize that one and open this one. And notice this is based on ports. Alright, what are the source and destination ports? So source port is there. Destination port is there. What is the default DNS port number? Well, you guys should be able to realize that. I'll let you guys look at that up if you need to. Alright, determine the IP and MAC address of the PC. Alright, in Windows command prompt, which we're on, and I've actually just showed you guys this already, but let's go to, well, I got one command line open already. Let's go back to that. Alright, so I'm going to do an ARP-A. Alright, in our ARP-A and ipconfig all to record the MAC and IP address of the PC. Alright, so when I do this though, this is showing, you guys don't really worry about the 224s and the 255s, all that stuff, but just the 192.168.153.2, that's the default gateway for this virtual machine going out to the internet. And notice the IP version forward address of this PC is there. This is if you want to send a broadcast out to this network, that's the broadcast address, just for information purposes. Okay. So compare the MAC and IP addresses in the Wireshark results to the IP and MAC addresses. What is your observation? Well, hopefully they're the same. All right. You're sending a DNS request out to a DNS server to resolve that Cisco.com. So you should be the source. The destination is that DNS server to resolve that IP address. All right. So let's go ahead and close this back down. Expand DNS name system query, which I'm going to close it down. Datagram. All right. Then expand the flags and queries. Notice right here, flags. And then scroll down a little bit, queries. Observe the results. The flag is set to do the query recursively to query for the IP address to www.cisco.com. All right, so we should have a 1 bit for recursion desired, no query recursively, or do query recursively. So it's going from a URL to an IP address. All right, so we see that. All right, so explore DNS response traffic, and notice right here they didn't really talk about it, but notice the query. There's your query right there. Whose IP address, or what is the IP address of www.cisco.com? .local domain. Type A is a IP version 4 address. All right. Now explore DNS response traffic. Now that was a request. Now we're going to get a response. Notice the response is right below it. Select the corresponding response DNS packet. Select the corresponding response DNS packet has, or I guess that's supposed to say that has, standard query response. See right below it. And A, Cisco.com. So I'm just going to do it like that. Alright, so I'm going to close all this down again. Alright, so what are the source and destination MAC and IP addresses and port numbers? Notice right here, source MAC, or the source MAC with the OUI translated to the manufacturer where it says VMware. Destination is right there. Alright, source is here. 192.168.153.2, and destination is 192.168.153.130. So the source is the default gateway of my network, which referring to my network in VMware, and the destination is my virtual machine. How do these compare to the addresses in the DNS query packet? All right, notice, and you can look up here too, which is really easy. There's a query, all right, from me to the destination, and then down here from the destination back to me. All right. So they should be reversed. Expand domain name system response, which is the very bottom. Make sure I'm clicked on the right one. All right, response. All right, observe the results. Can the DNS server do recursive queries? All right. And I'm going to say, can it do recursive queries? Yes, because it's actually translating them right there. And the reason you see multiples here, this has an anycast setup where if you like large websites, if you send requests to those, they like say you're trying to go to cisco.com, you can go to multiple physical machines with one IP address. But that's beyond the scope of this course right now. But that's how that works. So it's to expand DNS response. Okay. Then expand the flags, queries, and answers. So flags. Notice response has a 1. Authoritative server is an authority for domain. So that has a 1. Everything else has zeros. All right, flags. Where's my flags at? I did flags. Queries. All right, notice. All right, and answers. So it's sending back the answers. Can the DNS? Okay, I already did that. All right, observe the common name or CNAME and A records. All right, how do these results compare to NS lookup results? All right, so you see common name, cisco.com, and it adds .aka, DNS.net, and type A, the address is the actual IP address. All right, so looking back, let's go to the command line again, NS lookup, cisco.com. So if we look there, notice this address is 104.112.45.74. Notice it's different, but it's still resolving. All right. All right, so that's how it compares. Now the original, I forget, I didn't really look at the original IP address, but it could have been different. All right, but not a big deal. Just realize that happens on larger websites. All right, and if you set that up like on Amazon Web Services, you could set that up where it load balances to different websites or different EC2 instances, things like that. All right, but we're not going to worry about that. Reflection from the Wireshark results. What else can you learn about the network when you remove the filter? All right, so if I was to remove the filter, it's going to show a whole bunch of stuff. Just look down through here. The big thing is notice all of these ARP. You got ARP requests. You got different requests coming from outside IP addresses to us, which were the .30 in my case. You got stuff going out there. You get a bunch of data going out there. Three-way handshake for TCP. All right, so a whole bunch of other stuff is going on. All right, how can an attacker use Wireshark to compromise your network security? Well, what he's going to learn, obviously, who's on that, what IP addresses are on that network. He can learn what kind of system you have. If it has VMware or VBox or something like that, he knows you're using virtual machines versus a physical machine. He's learning IP addresses. He's learning where you're going. All right, all this information is very valuable. Who's trying to contact you, things like that. But yeah, if he's able to get in your network and try all this stuff, he can learn a lot about what's going on. You can see like this, what's this TLS encrypted alert? That's some kind of alert on here. All right. But anyways, that's how they could use it. Don't want to make this video too long. We're at about 30 minutes right now, but yeah, Wireshark tells you a lot about a network. Because one thing you can do, and a lot of times it's kind of confusing, But if you were to ping a server on your network, and say server 2016 has, by default, it doesn't send back response ICMP packets if you ping it, you would think you don't have physical security to that server, but you actually do. And the only really, I guess probably the easiest, best way to do that, if you have Wireshark on your network, you can see where that packet, run Wireshark on your server, so you can see packets coming at you. It's going to drop the packets and all that packet through, but you can see where the packet reached your machine, and then your machine dropped it. All right, versus not having a physical connection to that server. All right, but it works really good. Yeah, I mean, I use this a lot to find out certain things. Now, say if the traffic is encrypted, obviously it's not going to show you what the plain text it looks like, but it shows you a lot of stuff on there. All right, but that's it. Thanks for watching.